Hello, and welcome to this talk that we've called Reusable Thoughts about the Reuse of Software. This is Trond Arve Wasskog, and my name is Audun Fauchald Strand, and we are both principal engineers at NAV. For those of you who are not Norwegians, we're going to talk a bit later about what NAV is. But first we're going to talk a bit about software and reuse. And some parts of this presentation is new, and some parts are reused from old presentations, which feels kind of right. So first we're going to talk a bit about reuse in general and how reuse kind of is a fundamental part of software development today. And then a tiny bit about NAV and a tiny bit about software. And then we're going to talk a bit about what we think are the important parts of reusing software, which we call reuse is a spectrum. And then we're looking at the socio-technical aspects, and then we're concluding at last. And we have 2 clickers, and we never tried this with 2 clickers, so it might be a bit strange.
Right, so the first section is called reuse of software is great, but impossible. And we're going to start in 1968, or actually we're going to start in yesterday's party. This is from the party. I heard it was a great party. I wasn't there. So it was the music and beers and everything was good. Now this is from 1968. This guy is called Douglas McElroy, and he played a big role in the early days of software. So he's known for Unix pipelines and made some command line tools like diff and sort and join and so on. But this picture is from the software engineering conference that the NATO held in 1968. It was a conference like this one, but it was smaller. And it was where they coined the software engineering practice. And one of the things they discussed at this conference was called the software crisis. And they were discussing that in electronics and components for the computers, they were progressing and industrializing, while in software they couldn't keep up. So the programmers couldn't improve as much as the electronics did. So they discussed how to solve that in 1968. And Douglas McElroy had this session called mass-produced software components. So they discussed how they're going to make software to be reusable for all kinds of computers and settings and environments already in 1968. And of course, there were only men there at the conference because the real scientists were doing rocket science. This is Margaret Hamilton doing showing the code for the moon landing computer. So she was not at the conference, she was actually doing rocket science. But I think it's important to remember that this time we're using punch cards as a medium for programming and for storing and for communicating software. So reuse was kind of different at that point in time. And also they were discussing mostly general functions. So the example for that Douglas McElroy had in this session was about the sign functions, the mathematical sign function. So that is kind of a general function so that not all companies had to implement mathematical functions. That was the level they were discussing at the conference. So going forward, in the 70s, a lot of things were expanding, and the real progress was on the steps for what was coming was for the personal computer. And it's kind of funny always to misquote people that say that, well, who will need a personal computer in their house? This is Ken Olsen, was the senior executive of DEC. Said that, oh, well, we're not going to need it. But that was happening. And in '82, you had this revolution. People were getting home computers. This is Bill Gates, a beautiful picture. You had the Apple computer, you had the IBM computer, and people were getting computers in their houses, and were standardizing and reusing operating system. So Microsoft was founded on copying the IBM operating system and standardizing it and distributing it on all the computers that were used in the homes. And you had the game computers like the Commodore 64 and Atari and all the other stuff was coming in the 80s. And also in 91, Minix was launched. That was the operating system that was to become Linux and actually runs the internet now. Almost all computers on the internet are Linux-based. So that was also kind of foundational for reuse of the operating system and taking over the internet that was to be. In 94, there was a book published called Design Patterns, The Elements of Reusable Object-Oriented Software. It is a collection of patterns, how to do different mechanisms for abstractions in a given context. And the main goal was to reuse patterns and software. And it was inspired by this book, A Pattern Language by Christopher Alexander, which is used in the building industry for building buildings and towns and physical things. So our industry is heavily influenced by how they're thinking in the building industry. But of course, there are some really large differences between building physical stuff and software. Like it's really abstract. You can't touch software. Software can change depending on the context. Like if you lose the power, the software wouldn't work. A nail always works. Mm. And you can change software after it has been built in all ways, both upwards and downwards and sideways, while physical buildings are more stable and harder to change. So the loaning of ideas from the building industry is good in some ways, but I think also it's hurtful because people outside the industry think that software should be more like building things. And in some contexts it is, but in many others it's not. And also I think that I've been in the industry for almost 30 years now, and when I read this book I thought this is my golden hammer. So I was making design patterns all over the place. And it was not reusable and it was not very sensible, but it was really beautiful. So the patterns disease, I think many of us has had that, but it's not a good thing. Anyway, moving forward, I'm from the Java community. So in 97, a technology called Enterprise Java Beans was published. And with it, all the promises of a reusable component market, so that you could buy components off the shelf and just build your applications instead of programming them. And I just checked now, and then the 2.0 specification of EJBs is almost 600 pages long. So it's really, really complex. And I can't get my head around how they actually invested all the time and people and money to make that specification. But in 97 and going forward, it was the hype in the Java community, and everybody was making application servers, making beans, and trusted that this was going to be the future, that you can reuse software and reuse components across your own enterprise, but also between enterprises. And IBM even made a really interesting project called San Francisco. It was I was at the Java 1 conference in '98 in the Moscone Center in San Francisco. So it's named after San Francisco. And it was a general component library. So you could just buy that from IBM, and you can configure it and make all kinds of business applications. That was the promise of San Francisco. Of course, it crashed and burned in a couple of years. But I remember that in the Microsoft community, it was COM and DCOM and COM Plus and ActiveX. The same buzz about ActiveX components, like dragging them into your computer environment and reusing components. So at this point in time, in the late 90s, it was really the buzz about making reusable components. And of course, all that crashed with the DLL stuff and all the things that were going on. And also, it was in the dot-com bubble, so I think that is the main reason why people could invest that kind of time and money into making these specifications, because when it burst, not much was left. And it's fun to look at what people that were in the industry. This is Donald Ferguson was hired at IBM at that point in time. They made an application server called WebSphere, and he said, "That's the biggest mistake of my life. I over-designed it." So we were trying to do good stuff, making reusable components and reusable applications, but it was quite complex, and it crashed and burned. So moving forward to 2004, something really interesting happened. I don't think it's the first time, but Google, coming from an academic background, published a paper about MapReduce. And this was how they indexed the web. And they wrote a paper about it to get other people to know about how they were doing the indexing using the MapReduce algorithm. And it's a good example of how you can use open source to deploy ideas into the industry. The Hadoop community was founded based on that paper, and the open source community started taking over also not only the operating system like Linux, but also for applications. And Google has continued by publishing their ideas, and the open source community has copied their ideas, and they're expanding into the application landscape. So that's a really good example of how reuse is done on a worldwide basis. Just a little example from 2012. I was at the software conference here in Norway. It's a conference for public sector and private sector in Norway, yearly conference, and I was criticizing the governmental architecture principles, which were published at the time. And my main beef was that there were nothing about testability or maintainability and observability and all the ilities that I thought was important at that point in time. And I was really against the principle of flexibility, because the principle said that making software in public sector, in making that software, you should make it flexible enough to be reused in other contexts. And I think that's a really bad idea to invest in that ahead of knowing if it will be reused. So and I was picked up by the paper, and it was in this article. So, but I think that's kind of the foundation now for what we're coming into now in this presentation. That we really think that speculating about future reuse is a bad practice. So just fast forwarding, we had the cloud promising standardized components and standardized software as a service. It's getting better, but it hasn't solved our reuse problem. We had microservices. Also, some companies are saying that are promising that you should have a component market for microservices and can buy them and deploy them as you wish. Hasn't happened yet. And also, some people think that that AI will save us. That you can get code produced by AIs that will replace developers. And I think it's kind of both fascinating and ironic that the solution here proposed by, for instance, the Copilot people is that, well, we reuse by copying other people's code. We see it here and copy it here, and then we just distribute it. I don't think that's a good idea, and don't think it's good for maintainability. Just for the Norwegian speakers or for those who Google Translate, this article, have a reference there, is really good for having this overview of how we not have succeeded with reuse for many years, since 1968. And ending the introduction, reuse has been tried many times in many ways, almost since the beginning of software. And there have been improvements, like Linux and MapReduce and all the stuff, but we are still failing on a regular basis. And we probably should reuse more than we do. And all the non-software people obviously think that, why do these people have to make it again and again and again? And that's the really hard part. So if not impossible, reuse is really, really hard.
So that was kind of the overview part, and looking a bit backwards to see how reuse has been used in our industry for 40, 50, 60 years. And now we're going to give a short introduction about NAV so that everybody knows what NAV is. So basically, NAV is the biggest organization in the welfare state in Norway. You can almost say it's an organizational experiment. In 2006, and they merged together the three biggest organizations doing helping people get back into work and giving people financial security and helping poor people. So all of this was merged into one organization because they thought that then we could get more synergies and we could reuse more functionality and data and code across these organizations. This was almost 20 years ago, and we haven't really seen that much of a gain from that yet, but that's also because we have incredible amounts of legacy software. But just to give a bit of an example of the size here, NAV pays out about a third of the federal budget in Norway every year. It's this 600 billion Norwegian kroner. And that's quite a lot. When you talk to the people owning the payment system, it's impossible for us to make them think any amount of money is a lot. It's always just, nah, that's nothing. And how we're organized, we are 600 developers, about 20,000 altogether, but 600 developers, and we have 200 teams, and we group the teams into what we call product areas. So we have product areas for the different functional areas of NAV. We have something for the health benefits, and something for the work-related benefits, and something for the family-related benefits, and some platform areas. And if you look at what we do technologically, we normally say we write mostly Kotlin, but we have mostly Java. And we use Python and Go whenever that's reasonable. And we have loads of different databases, but we try to use as much Postgres as possible. But it turns out it's quite difficult to get out of Oracle, for instance. We use both Azure and Google Cloud. We store all our code in GitHub. And as I mentioned a bit, we have loads of mainframe software. One of the most important systems at NAV is about 44 years old. It's mostly Cobalt, and if that would stop work today, it would be on the front page of all the newspapers of Norway. And we probably had to go back to work straight away. And if you look at the size, we are big proponents of open source software, so we store all our code in GitHub. Altogether, we have 143 million lines of code. Not all of that is open, but if you go to that page, you can look at a lot of the code we write all the time and see how what architecture choices we've done and how we actually implement the different systems we have.
Right. So, just reflecting on the number, 143 million lines of code. That's a number, or the code has to be maintained by people. They have to understand it, change it, deploy it. So it's a lot of code to handle. And software is eating the world, cliché. But it's everywhere. It's in your phone. It's in your dishwasher. It's in your car. It's in all your little stuff in your home, and it's used by all industries and all markets. So for job security, I think it's a good thing for us. But it's really hard to think about how we're going to maintain all that software, because we are using it more and more for supporting our daily lives. And it's getting really critical for the society that the software is working and is helping us and is doing what it's supposed to do. For this session, I think it makes sense to think about what part of software is more close to the infrastructure, like networking and disks and things that are not very functional or domain specific.
Logging.
Exactly, and also on the other side is the domain software. That's the hard part. We are at now we are developing systems that are helping people with benefits, and that's you can buy that off the shelf, or you can't get others to make that for you, or you have to hire people to do it, because that's the other dimension. You can get software as a service or off-the-shelf software. Like SAP or Salesforce and other packages that can help you doing things in specific domains. While on the other side, for our rules, for Norwegian law, it's you can't get that off the shelf, so you have to make that yourself. And the kind of software that we are talking about in this session mostly is about the custom software that's domain-oriented, that we make for ourselves. So like Linux, the operating system, and all the software for supporting the servers and the virtualization and the networks and all the stuff, we use that and we buy that. But for all the other stuff that we are making it now, we have to develop it ourselves.
So what we're going to talk about now is to try to describe the different ways we've seen software being reused at now, and when we think it will work, and what we think are the pros and cons of the different approaches. But as Trond Arve talked about at the start, there's been loads of talks and discussion and old people drinking beer and discussing how to do reuse of software on a large scale. And we have loads of success stories like Linux or Kubernetes or different things. But we want to focus here on the custom domain, all the code that Nav writes every day, how we can achieve reuse with that software. And as Trond Arve was saying, one of the main important things here is the balance between writing less code, because 143 million lines of code is a lot. But also you have to try to avoid having tightly coupled systems. And balancing those two can be quite difficult, but we'll try to show different techniques that we've seen work and not work at different kinds of problems and for different contexts. So basically the main point here is that when you want to reuse software, it's a spectrum. There's many different ways of doing it. Sometimes you get less code and tightly coupled systems, and sometimes you want to have very loose coupling, and then you get more code, for instance. So we'll go through each and every one of these different kind of techniques. And this is quite heavily inspired by this book, or specifically chapter 14 in this book from around 2000. The blue book about the domain-driven design. And this book talks about how you model your domains and the different techniques for integrating different domain models. And the point there is the same. There's many different ways of doing it, and sometimes you want loose coupling and sometimes you want tight coupling. Yes. So the first part is one configurable business application to rule them all. So basically you have some kind of application and you think everybody can use this application. All they need to do is configure it differently for different needs. So the red team has made this application. I've given a red configuration file. And then the blue team comes and just puts a blue configuration file into the same application. And then they can then reuse everything. So when you think about the amount of code, that's really good. Then you basically have this one application that's maintained by someone, and everybody reuse that. And this is good if you have a common process, but it's sometimes quite difficult to understand if the process is common or not. At NAV we had this idea a few years back that all our benefits can be handled by the same system, and you just configure it accordingly to the laws and the use cases. And that turned out to be impossible. Although there's some parts of the law that are the same for everything, there are so many differences in the different benefits that it's impossible to handle it by one application. For instance, we have some benefits that are quite sad for the users, like when you get sick and you need sickness benefits. But there's something that's much more a happy situation in life when you get a kid, for instance. And handling all of this makes it impossible to just use a configuration file for differentiating between them. But I've also seen this work. At my last job, I worked at Finn, which made some kind of a aggregator for flight searches. And then we had to integrate with about 20 different suppliers of flight data. So what we did there, we had 3 different teams, and they each made their own integration. And then we looked at the different solutions and figured out which one was the best. And then we saw that the process for integrating with these suppliers was the same. So all we had to do differently was mapping the data. So we created this very structured process in the library. And it took one developer about 2 hours to integrate each one after that. Before that it took us a few weeks to make the first one, but after that it was really quick. The problem, of course, is that before you start this implementing everything, when you don't know too much about the domain, everything seems the same. You think, I can always use this, everything fits this process, I think it does. So you think that you can make an application that's configurable and will fit every problem. And when you kind of bought into that idea, you want it to work, so we try to make it work in more and more problems, and then you increase the scope, and then you end up with some kind of general application that doesn't really solve your problem at all, or doesn't really make it any easier. You just generalize everything. And this basically means the coupling is very tight between the different implementations. The next technique is a quite common one, shared libraries, which also has a modern evolution called sidecars. So we have some kind of functionality that the red team is writing, and you use that as a part of just import this library into your application, and then you can use it. When you're into a more cloud-native world with containers, you can also say, I want this piece of code to be a sidecar, so run it in a container next to your main container, but inside the application. And the good things here is that you can have controlled ownership or shared ownership. If you make good libraries, for instance, for logging, everybody uses it, and you have one place to define all the logic. And what we've seen work quite well is some kind of a shared inner open source model where all the teams work on the same library and extend it according to their needs. That might be problematic, but sometimes it works really well. If you see that gets too big, you can assign the ownership to one specific team, and they own the future of that, or the features of that library. But now we have a library called Wonderwall, which is an integration part with the Norwegian Ida-porten, which is kind of authentication for all Norwegians. And having that as a separate component makes it much easier for all the teams to use that functionality. But there's problems here as well. If in a large organizations have loads of libraries and there's many different teams using them, it's difficult to keep everybody on the same version of the library. So we need to have some kind of tooling or something to avoid the different teams using different versions, and then you have maintainability hell. And of course, you might end up with some kind of a left pad problem where you make libraries for everything, and that complicates the software development too much. So the important part here is to focus on the ownership. So the next kind of pattern for reuse we've seen is a shared service. And this is basically where a team has some functionality and they expose this as a service. Back in the days, this was often done in bigger monolithic architectures, but now it's much more common to do this as a microservice. And a good service should wrap all the business functionality of some kind of capability. One example from Nav is the service that handles the payment of all the benefits. So all the different benefit applications, they calculate and figure out how much money a user should have, and then they send this information, social security number and amount, to this service, and they handle everything. If the user doesn't have an account number, they send a payment order to a manual case working so that they can figure it out, and the service handle tax and everything like that. So everything is kind of hidden behind a good API that makes it easy for the different teams to use this functionality. And there's different ways of handling the ownership here as well. Some teams put these kind of services into a platform or a common services team, but other times we've seen that this works where one team making a normal business application has a good service and they expose this to the rest of them. It might be a bit more difficult over time with ownership because it's difficult to both make your own application and expose a service that everybody should use. It's difficult to prioritize them. So the pros here are quite, I kind of mentioned, it hides the complexity and it's clear boundaries between the service and the different applications. But finding those boundaries and keeping them is quite difficult over time. The world changes and the requirement changes, and then you need to have the boundaries respond to those changes quite well. And at the same as most others, you need very clear ownership. You need to know which teams owns these services. A bigger way of doing these shared services is by making platforms. And then you group together the different shared services that are connected on a domain level, or for instance, all infrastructure services, and make one team or one group own all of them together and make a coherent platform that is easy to use and removes a lot of cognitive load for the different teams. Greg Hope, in his platform strategy book, defines a service as something that raises the level and makes it easy to build on top of something. And at NAV, for instance, we have an application platform that's called NICE, which handles all the different things you need for running an application in the cloud. You have deployment and logging and observability. And all these services are grouped into one team, and they make it very easy to run such applications. The important thing here is to have a product mindset when you create this, so you understand that you solve the problems of the different teams. At now, we normally say we have a golden path. I think golden path came from Spotify back in the days, but we want to make it easy to do the right thing is what we normally say at now. So instead of making all the teams using our platform, we just make good tools, and then the teams choose themselves to use that platform. We've seen the same pattern on a more front-end based thing. We have a design system, which works kind of the same way. They make the tools needed for all the different applications at NAV to work, to have a conform look and feel. And the pros here is that this scales quite a lot better than the shared services, because we have one group that can think strategically about what they need, what services they need to expose. And you have a really good boundary between the application and, for instance, the application platforms. But the problem is this can become quite big, because if it gravitates and you get more and more functionality into this platform, and then you you stifle the innovation, and everything becomes too similar. And at least at NAV, we've seen that the amount of people needed can grow quite a lot, and it might not be efficient anymore when, for instance, functionality from outside NAV comes and does the same thing, for instance, for cloud. This pattern is not something I've seen a lot, but I've seen it a few times. It started, at least I became aware of it first, from cloud vendors, where many different cloud vendors say they have Postgres compatible databases. So you can buy a database from Azure and Google. I think Google calls its database AlloyDB. But the interface means that its database looks entirely like Postgres. But the implementation is Google's own, and it's not really a Postgres database. So they have a common API and many different implementations. And this specifically makes it easy for the consumers of these different services to change implementation. So it reduces the coupling to the implementation. But at the same time, you need different teams to make these different things. But now we've seen this when, as a part of our big governmental reform, now all the different benefits it now needs to send information to different pensions providers about the amount of money we paid out to our users. And so we have loads of different consumers and loads of different applications on the back end. So what we could do is for all the different teams on the back to integrate and make one big database that serves this data for all the different pensions providers. But that means that we need to coordinate and cooperate between the different teams at now. But instead, we've created a common model that says all the teams at now needs to implement this API and make it available to the different pension providers. So they can use the same model for their APIs, but they need to integrate with each application. And the pros are mostly on the supplier side. We don't need to coordinate, and we can have different teams working at different speeds and prioritize differently. And we have to make the consumers, it's easy for them to integrate with many different services. But making a common model is really difficult. I presume a lot of you try this, and trying to figure out a way that fits every different problem is difficult. And a lot of the time, things aren't as equal as you think before when you just start looking into a problem. And then another way we've seen at now is using Git for reuse. So basically we have seen teams having an application and another team wanting to reuse this application. So they created a fork, Git fork, and they have their own copy of the application. And they try to keep up with the changes in the first application by rebasing commits into their new application. And they're really happy for about 15 to 20 minutes. And then they understand that, well, this change isn't exactly what I need, so I'll change it a bit. And then the next change is more difficult to handle because then the commit doesn't really fit your code anymore. So we tried this with some of our bigger applications, and I think the longest I've seen or I've heard that this is actually given value is for a few months. But then the team that made the first application, they split and started to make the second application. Half the team started to make the second application, and the rest of the team were back on the base application. So they worked together and had a similar style and a similar architecture. But still, it only worked for a few months before the requirements were different enough, so they couldn't really keep up that link that you need to be able to merge commits into application. So in theory, this seems like a good idea, but in practice, it's really difficult to handle over time. But the initial boost can be quite valuable. You can get a lot of the thought and code that's gone into the first application, and you can start on a higher level. Yes. And then the most common one that Trond mentioned a bit, you just go on Stack Overflow and you copy some code. And this, I think, well, this is probably 99% of all reuse, also internally. The problem, of course, is that people don't really know which other code is the best to copy from. So they just take they ask someone they know, and they'll get an example, and they use that code. So one way of doing this better is have some kind of blessed list of good examples. But to have that, you need to have people that can look at all the different 2,000 applications and find a good example, and that's really difficult. So again, you get some initial productivity boost, and you get loose coupling. There's nothing coupling you into the old code, and it's really easy to do. Also, there are some things that you might not think about, but for this to work, at least you need your organization to use the same programming language. And you probably need to have at least similar architectures for the different applications for this to give any value at all. but you don't really get any feedback. We tried at NAV to have our private Stack Overflow instance, which seemed like a good, although a quite expensive idea, but it turns out that people only use Slack anyway. We tried everything we could to route people into Stack Overflow, but I still asked the people they knew on Slack in a DM for help. So we didn't really scale. And then a really, also a good one, reusing ideas and knowledge, just people talking together and learning from each other. And this works quite well. We can help it by, for instance, rotating people between teams, making a system of that so that it's easy for people to spend some time in a different team. And you can have structured learning, and when you're really good like Google, you can start to produce white papers, and this scales really well outside your organization. But internally, it's, oh yeah, and here we have the other option of using Copilot, or ChatGPT, or different large language model, which is kind of a way of, it's either just copying code or it's reusing knowledge. It's probably depends a bit on how good or how lucky you are with the different examples. But at least there's new things here happening that might make this more usable. So the pros here, there's no computers involved. The cons is there's loads of people involved, and that might not be the easiest for everyone. It scales quite well when you have an organization with good communication lines. And the last possible pattern is to have no reuse at all. And this seems quite strange sometimes, but a lot of the big progresses in the world have been doing this. I listened to a podcast about how Lockheed Martin created a skunk work organization that basically created loads of different airplanes that helped us win the World War II. And they did this. They took a part of the organization, put them in a different part of the country, and said, you're not allowed to talk to anyone in the old organization, you just do your thing. And that created big amounts of innovation and loads of new technology. There's no real benefit to the old organizations, but just saying you don't have to think at all about the old thing makes it easier to create new stuff. But this basically is good for small things, but you in a big organization that has a long perspective, you probably have to make some kind of system to learn back from it or something. But it's a good way if you really want innovation. So this is the different patterns we've seen on how to have reuse work on a technical level. But it turns out this isn't the only thing that's important to think about.
All right. So we are going to talk about some of the social technical aspects. Audun has mentioned the patterns and how we're going to think about this. In NAV, we have a technical direction, as we call it. It's a presentation about what things that you think are important for NAV. It's in Norwegian. One of them is the one I highlighted, which says reuse should be discovered, not designed. That's on the left-hand side, and we are moving towards what we're calling a product organized reuse. So the thing is that, as I mentioned, in 10, 15 years ago, we were against designing reuse from the start when we were making applications or making systems. And we said that, well, we will reuse, but we shall discover it, right? When we reuse something the second or third or fourth time, we will make some kind of structure to reuse it. So that's on the left-hand side. But what we have learned since then is that we see a lot of candidates for reuse when we are developing our applications, but we are not able to reuse them. So even though we see the candidates and we know that we should reuse things, we are not able to actually implement that reuse. So now we're trying in NAV to move towards what we call product organized reuse. And what's that? Audun mentioned the product areas. This is another illustration of our product areas with the different people and the different teams, smaller or larger. And this is also, in effect, the architecture of NAV, or what's going to be the architecture. Because we are, of course, influenced by Conway's law. Is that how we organize? Is how we develop and deploy our systems. So, for instance, the retirement pension scheme, which is the biggest one in the right-hand corner. I think it's 120 people, and they are concerned about pensions, about retirement pensions. And they are not, they don't have any incentives for making software that's reusable for the other product areas. So they are optimizing for their own system, right? So when some kind of component that they are making is potentially reusable across other product areas, we don't have any structures or incentives or mechanisms for using that. And also the other way around, when something is made in another product area that's usable for the retirement pensions area, it's hard for them to reuse because they don't get any support from the other product areas. So this is where we are, and this is what we're trying to getting better at this point in time. So one example from some years back is that when the current retirement pension system was built from 2006, 8.
Yeah,
Ish?
8,
Yeah.
I think.
8, yeah. It was developed and deployed, and then the system for disability benefit, uføretrygd in Norwegian, also was to be realized. And because they were in a hurry and didn't have the people or the money, they decided to make the disability benefit on the same platform, on the same system as the retirement pension system. And of course, now it looks like this. So the people in the product area, they then have to know both about retirement pensions and disability benefits. The rules are intermixed. And if you want to make some changes in the law for pensions, you also have to consider disability benefits and the other way around. Because this is maintained by some people in the same system, in the same context. And also, I haven't had it confirmed, but I think that some of the law is influenced back by the system because it's hard to make the changes. So this is what happens when Conway's law is in effect, and the socio-technical aspects influence how you are working. And this is natural when you organize like this. So it's really hard now if you want to split the two systems. It's a really big job, and it's really hard to do that, and it's going to take many years. And as Audun mentioned many times in his patterns walkthrough, the main problem is about ownership. We need to know who's going to maintain this in its life cycle over many years. So it's not enough to solve the problem technically, because that's the easy part in many ways. We know how to do the algorithms and deployments and scaling and stuff. That's the easy part. But the ownership and the people and how to maintain it over time, that's the really, really hard part. And we have to account for that when we are designing our systems, and not only our technical systems, but our systems of people and product areas. And also, as I mentioned, we have to have a product mindset when we make our systems. And what that means is that you have to, instead of mandating, use this to the teams, you have to make it attractive and make the teams and people choose how to use things. You have to market it. You have to think about how you're going to maintain it over time. And you have to have documentation and make people actually want to use it and help them use it over time. And the NICE platform that has been quite a big success in NAV has used exactly that approach. So nobody is forced to use NICE as an application platform in NAV, but in effect, everybody's using it because it's the easy path. And it's marketed. I think that you have used a cake during development.
And you have T-shirts?
And T-shirts, merchandise. And a really big part of this is because in the developer community, people want to have the choice, and they want to decide themselves, instead of having some people saying that you have to use this. So it's really important to have a product mindset. We are discussing now and want to solve a common platform for case handling for the smaller benefits in NAV, like the funeral benefit. And there are a lot, like tens or maybe hundreds of small benefits that NAV is providing. And we cannot make a complete system for each one of them. So we want to make a general platform for the small benefits, and have some common services and common ways to handle that. That's just in the making, so we haven't solved that yet, but we have to address that when we are modernizing how we're doing our job in NAV. A small example was for payment, for getting the money to people. We have a system that does that in large, but the interface to that system is quite hard. And for the teams that are doing the case handling and are translating that to benefits or money on the account for the user, that's really hard. So there was an adapter that was kind of translating the hard parts of the payments to the teams, made by one team, and then it was copied. First it was forked and used by other teams, and then the third team did the same, and it was copied. And I think when there were 4 or 5 teams using the same adapter, we sat down and thought, well, perhaps we need some ownership, and established this little team that was given the ownership of this adapter component and was able to provide it to the other teams and maintain it over time. So we had to actually allocate people and form the teams with the product leader and with the developer and all the other roles that's necessary for a team to handle this over time. And we're thinking that perhaps this should be a pattern that we're using for other similar needs as well. When you see that things are actually reusable, we can use the same structure, forming a little team, or having teams that are actually owning these services over time. Another small example is for user applications. You have to apply for benefits in NAV, most of them. And then you have a web solution, and when you are working with your application, perhaps you have to log off because you have other things to do, or you have to get some documentation or whatever. So most of them have some kind of temporary storage. And of course, most of the teams are solving this by themselves because they are only concerned by their own applications and not everybody else's. So they have different solutions for both technically how they store the applications, and also how they make the law how they consider law and so on. So I think that both reflect the law that can we store the application for you, and how long can we store it? Do we need to delete it and so on? All the rules for your personal data, but also for the technical stuff that it should be a common solution. This is a small example how we can work across the teams that have similar needs, even though the benefits are different. So we are working on that one. And in general, we think that we are using a lot of time with the law in now that we have to. That's our requirements, so to speak. And some things are the same, and some things are different. But I think that if we can get the teams to reuse the law workings across the teams, that should be a real benefit for them. So they don't have to do the same job to approve the same things. So that's also one thing we are working with. And just one example, the last one from just a couple of weeks ago, we were discussing authorization, and we wanted to discuss how we could do that in a centralized way, have one component doing authorization across all the backend systems. And of course, we started discussing the technical solutions. How can we do this technically? But then somebody said, oh, well, it's really easy kind of to get the technical solution for this. But you have to remember, how is this going to be maintained? Who's going to own it? Who's going to deploy it? Who's going to be responsible when this component fails and all now stops? And so on. So the social technical aspect is always important to remember when we start making common components that are going to be deployed across the organization. And we said that reuse is hard, and it is, at least for the blue component in the middle, which is the core system. But the other things that are around this this blue box is actually things that we are reusing, like sending letters and journaling things and paying the payment service and so on. That is actually reused. So it's not that bad as you can think. But what we're trying to solve is how to reuse more in the big box in the middle. That's the main issue that we are struggling with.
So basically, reuse is good, and it's not totally impossible, but you need to think about a lot more than just coding or copying code when you want to have reuse that works over time. And of course, we've seen from the outside world that open source is an incredible invention. There's so many things we don't have to think about and don't have to code and do because we can just download stuff from the internet, and that really works. So the question is, how do we get this to work inside the organization as well, at least at some kind of similar success rate? So first of all, reuse isn't either or. There's a spectrum. There's many different ways you can reuse code, and you have to consider your context and the pros and cons of these different techniques when you look at how you want to achieve reuse of your code in your organization. And even more important than how we do it technically is how we do ownership and how we do make this fit into your team architecture. So that was our talk. If you want to be a part of this, you can go to that address and look at our newest commercial and consider working to help save the Norwegian part of the world. So thank you.
Thank you.